Hi, my name is Matthew Paulino, and my title for this project is Automatic Light for Energy Efficiency and Providing Lights for the Elderly People and KAPCC for Safety in Their Household. My advisors for this project is Professor Aaron Hanai and Professor Jacob Tyler. Stage. As you all know, the candle nut tree, or known as the kukui nut tree, produces kukui nuts that are super rich in oil content. Traditionally, the Hawaiians would extract the oil by means of grinding the meat part of it, which is the middle of the kukui nut, and use it as a source of light. The light that was made from kukui nut oil would be used to guide them in the pitch darkness of the night. The devices for the light source that the Hawaiians used would range from a candle-like device to a stone lamp. As time went on, the way we get our light source changed from burning the kukui nut to using technology. The purpose of this project is to create a setup that can adjust the LED's brightness based on the room's brightness. This will help reduce the amount of carbon footprint because traditionally Hawaiians would burn the oil, and this will provide safety to keikis and elderly. To approach this project, the circuit layout, which is this picture down here, with our Arduino board, photoresistor, and LEDs are needed. To connect all the components together, jumper wires, which are these right here, are needed. A photoresistor, which is this thing in figure 1, is made of a semiconductor material that lets electrons flow when photons are hitting the top of the photoresistor. Since the LED is bare, without any type of cover, the LED needs to have a lampshade, so the light has more of a direct / diffuser lighting. So a custom lampshade was made from origami that has an interior layer of tinfoil. The coating part is the most important ingredient that brings everything together. Arduino is programmed to read the light levels in the room by what the photoresistor is receiving. The photoresistor has a code that has a max and minimum threshold that gives the boundaries of how much the photoresistor should receive. The system has a map function where it can scale the values of the photoresistor to the values of the LEDs. With the help of the map function, the LEDs adjust to what the photoresistor is receiving. In this slide, in figure 2, this is just kind of an idea, a broad idea of how the code works. As a result of the project, the photoresistor responded to a light because of the changing of LED brightness, as you can see in figures 3, 4, 5, and 6. So in figure 5 and 6, you can see that there is a good amount of light that is being emitted by the LED. So in figure 6, this is just printer paper, A4 paper, if you must, is just used as to scale to see how much light is being shown, or how much light is shining from these 5 LEDs. Also, in figure 4, you can see me holding the photoresistor that is reading the room's brightness, And as you can tell, my room is kind of bright. This is during the day, and as you can see, my LEDs are turned off. So with the help of the custom lamp shade with the tinfoil interior, this helped to create that kind of directness slash diffuser characteristics, kind of like a desk lamp. Like in all four of the figures, I kind of make it where it's sort of like a mini desk lamp. So also the tinfoil also really helped with making it a bit brighter and maintain a certain direction of light without any light leakage. So light leakage, like light is not going in the direction that you want it to be, so it just leaks out on the side. So overall, this project has been successful with the Arduino using the code and getting readings from the photoresistor. There has been many difficulties during this project. An example of a challenge would be understanding the different functions of the code, such as thresh function and the map function. A future plan for this project is probably to add more LEDs so it could be a bit, oops, sorry, my bad, a bit brighter and to implement longer jumper wires so the light has more of a surface area on top of my desk rather than having the light shoot out at an angle sideways. As you can see in figure 6, it's kind of shooting out sideways. So, yep, this is my references. And a special thanks to everybody down here that helped me during the project and helped me assemble this uh, poster. And yeah, thank you for listening into my project for STEM 295. And thank you for listening.